Hi, in this video I am going to explain about high performance liquid chromatography. Introduction. High performance liquid chromatography is a product of the scientific effort towards optimization of the conventional column chromatography. Because a conventional chromatographic experiment takes long time. To reduce the time of experiment, one can increase the flow rate, thereby reducing the retention time of the solute components. This reduces the time of experiment. It also reduces the efficiency of the column because the solute components undergo lesser number of equilibration, that is, plate number is reduced. To overcome this, if one uses a longer column, the diffusion effects increase and the peak is broadened. To increase the flow rate, the pressure has to be increased. The conventional supports can tolerate pressure only up to a particular limit. At higher pressures, their structure is affected, thereby causing flow rate anomalies. All these factors were efficiently resolved with the development of high-performance liquid chromatography. This method uses an extremely high pressure up to 8000 psi. It is equivalent to 550 bar. The flow rate is high and the experimental time is shortened considerably. Also, there is no loss in efficiency because the support particles are very small and more or less in uniform size. The lateral diffusion is less because of two factors, the smaller particle size and the enormous pressure, which reduces the time that a solute spends in the column. Due to this, band broadening is minimized. High performance liquid chromatography is therefore highly efficient. This technique is suitable for both analytical and preparative method. Advantages of high performance liquid chromatography. First one, separation of polar compounds such as drug metabolites, which in general are poorly resolved by other techniques. Second one, it may employ the principles of adsorption, partition, ion exchange, exclusion and affinity chromatography. Schematic diagram of high performance liquid chromatography is shown here. Let us have a look into the parts of HPLC. Solvent reservoir is to store the mobile phase. High pressure pump is to push the mobile phase through the column. Then injection port. It is a device used to inject sample into the mobile phase. Then column, in which separation takes place. Detector is used in detecting the concentration of the sample components as they come out of the column. A recorder is to produce chromatogram. Solvent reservoir. Solvent reservoir should meet the following criteria. First one, it must contain volume enough for repetitive analysis. It must have provision for degassing the solvents. It must be inert to the solvent. Solvent degassing within the reservoir is performed usually by heating or by treating it with ultrasonic sounds. If there is a single solvent or a fixed proportion mixture of two solvents, then isocratic separation can be carried out. If there is two solvents with variable proportion, then it is achieved by gradient elution. Pump. Pumping systems can be said to be the heart of high performance liquid chromatography. By producing reproducible high pressures, the pump is a major factor in obtaining high resolution, high speed analysis and reproducible quantitative analysis. A good pump should have the following qualities. First one, a stable flow. Second one, it should provide solvent flow rates of 0.5 ml per minute to 10 ml per minute. Third one, a constant volume delivery. Fourth one, it should produce high pressure up to 6000 psi. Fifth one, it should be adaptable to gradient operation. HPLC pumping systems. There are 5 types of pumping systems employed in HPLC. First one, liquid displacement by compressed gases, that is also called holding coil pump. Next one, pneumatic amplifier. Third one, piston or diaphragm driven by a moving fluid. Fourth one, reciprocating piston type pump. Fifth one, syringe pumps. Sample injection. 2 methods are available to introduce the sample as a narrow band. First one, sample is injected using a micro syringe when the pressure has dropped to almost 1 atmosphere after switching the pump off. This is called stop flow injection. Another method employs a small volume metal loop which can be fixed with the sample. An appropriate valve then channels the eluent from the pump through the loop directly onto the column. The sample is thus carried spontaneously with the eluent to the column. The high-performance liquid chromatography columns are made up of stainless steel, glass, aluminium and copper. Stainless steel columns can withstand pressure up to 8000 psi. Straight column of between 10 to 50 cm in length are generally used. The internal diameter of the column is usually 1 to 4 mm. Detectors. First one, ultraviolet bar visible spectrophotometers with wavelength selection range of 200 to 800 nanometer. Second one, fluorescence detectors. Third one, refractive index monitors. These are the commonly used detectors in high performance liquid chromatography. Other than this, mass spectrometer is also used. Thank you for watching this video.